Hello guys, welcome back to my channel. And today's video is in continuation with my previous video. That's where we have discussed about layout parsers model. That's where we learned how to detect different regions in a document. It could be image, right? So we took the example of images. And that's where you have seen two different models. One is fast RCNN and another one is like mask RCNN, right? So here you see like this is the kind of reasons were detected. Okay, but as we ended, we seen okay. So there are many more reasons. For example, these date and location. Okay, these up to here we were able to detect. But for example, here, so this outer boundary it has detected, but not the inner boundary, right? And some places it has even left. So for example, this reason is not detected. This is the main reason. So then we thought, okay, what further we can do? So we decided, okay, we can fine tune a particular model, say mask RCNN. But before fine tuning, we thought, okay, it could be a costly in terms of resources. So we can also try out ensemble learning. So that's where in today's video, we are going to talk about ensemble learning, how it might help in this particular case. Okay. So for that, let me give you some kind of background. So how ensemble learning works basically, I mean, the same concept coming from basically machine learning. So I have created some notes for you. So let me paste it here. Okay. So for example, ensemble learning in layout parsing combines multiple models that we already know, right, from machine learning. And those model combination could be different layout detection model. It could be detectron based model that is from Meta or YOLO or any other. Okay. Of course, it should support, basically, we are using layout parser, so it should support that. And then it could be different OCR engines. So in a moment, you will see, okay, we will detect the different text blocks. And for that, you can use tesseract, parallel OCR, or any other easy OCR or any other, basically, or different document classifier. Okay. So basically, when classifier comes in picture, so if we are identifying some text blocks as a title, okay, so we are classifying this is a title, this is a text, this is kind of table, this is figure. So for that, different document classifier can be used. Okay, and what are the common approaches? So approaches like a voting approach, that's where like multiple models detect reasons, majority decision wins. Okay, and confidence based, so choose a detection with highest confidence scores, right? And what is IOU? So it is nothing but the intersection over union. So that is what we will be looking for today. Okay, so this is the method we are going to use. And then another approach could be hierarchical, use different models for different layout level. Okay, so today we are looking for IOU, that is intersection over union. Okay, in maybe another video we can look for another approaches. Okay, and of course there are benefits, improved accuracy. That's what you are going to observe and realize in a moment. Okay, so this is the base. For example, here you see these inner boundary boxes are not detected, only outer boundary detected. And even in this case, like not ever, so for example, if we want to identify each individual line, so for example, there could be a boundary for each line, right? So that all can be detected. So that's what we are going to see with the help of ensemble approach. Okay. So for that, I have already kind of created a method called ensemble detection. So let me paste it here. So yeah, so here, so I have not pasted all the code at once, so that like I can explain one by one, and that's where like you can also execute the code along with me. You can pause the video, you can write the code, and then you can execute. Okay. So first method I create like ensemble detection, and here the input will be our image. And here I have created two models. So like one is mask model and one is fast model, because these are the two models we have seen in our previous video. Okay, so that's where I started this layout parsing series. Okay, so the very first model mask RCNN, and with these parameters. So the first one is like it defines the confidence score. So we are setting the threshold very low, 0.2. Okay, so that it don't leave any reasons. I mean, majority it select. and then the overlap confidence 0.1. Okay, and then we have defined the label mapping. So this is where document classifying comes in picture. And then we have another model, that is fast RCNN, and here again we define the same configuration. Okay, and then based on these two models, we'll kind of identify the layout. So one we name as mask layout, another we name as fast layout. Okay, and then we need to combine, because we are going to combine these layouts, and based on IOU, which you will see in a moment, based on IOU, that is intersection over union. Based on that, we'll detect the unique and intersected layouts, basically. Okay. So once I write the code, you will have more understanding. Okay. So let me just define it. So it will not give any output at the moment, because it's just the definition. Okay. Next, let me show you the pipeline, basically. So what pipeline I am going to build. Okay. So let me define the complete pipeline for you. And that's where you'll understand, okay, what we are going to do. Okay. Yeah, so this is the complete pipeline. So of course, right now it is showing error because we have not defined this method. We'll define one by one. Okay. So of course, this is the function name. So you can give any name and it accepts the input. Okay. And the very first method in the pipeline, it will call ensemble detection. So what ensemble detection is all about, what we just learned here. So it will basically combine these two models layout. Okay. The next one, what we are trying to identify based on tesseract, we'll just try to identify the text regions where all we have the text-based region, and here we'll give the input as image. Okay, so let me give you the text-based region method. So what we have here, so let me define it here. Yeah. So here we have detect text region. So as we are calling from here, detect text region. Okay. So here what this function will do, this function uses tesseract OCR to detect text regions in an image. And what are the key operations I have written for your reference? So it uses tesseract OCR to detect text and its location, group adjacent text boxes into larger boxes, blocks basically, and converts detected regions to layout parser format. And then finally it returns the layout containing text blocks coordinates. Okay, so this is the like high level operations we are going to do in this one. Okay, so it is giving error, PyTesseract is not defined. So let's first kind of install and define PyTesseract. Okay, so what we can do, basically we can import. Yeah, and yeah, PyTesseract is not installed. So what I will do, I'll just install PyTesseract. Okay, so let me, what we can do, we can install at the beginning so that your code is clean. Okay, so I'll just install. Okay, so let me just yeah, so these commands will install tesseract. Okay, and till then we can, so it will install in the background. Okay, we can go ahead. So it will install, and we have imported that as well. Okay, so let me see if it has installed, or yeah, it has installed. So now we can import. So now it should not give me the error. Yeah, it ran successfully, right? So now we what we are doing, basically extract text and positions using tesseract. So here I'm using input, and output type will be from tesseract dictionary. Okay, so that's what I'm getting the data based on the text region. Now what we'll do, basically, we'll group the adjacent text boxes into blocks, because what we want to have like title and corresponding text very close by, right? So that's where like we'll group the nearby text. So that's what we are doing here. Okay, in this. So in all the kind of detected region as text, what we'll do, we'll strip, kind of removing the spaces, and we'll skip if it has empty. Okay, so we are just removing the empty boxes, and then get text coordinate. What it will do, basically left, top, right, all like 4 coordinates will get in X, Y, W, H. And then what we are doing, basically starting new block or expand the correct one. So ultimately here we want to group, right? So we'll just have all the text box, all the blocks with text which are not empty. So that's what we are doing basically here in this one. Okay. And then what we are doing, once we got those blocks with respect to text, will convert to layout parser format. So that's what we are doing here. Okay, and then we'll return that. So now in this pipeline, we have detected the text region. And again, we'll set the threshold for text region as low as possible, like that is 0.3, which is lower than the model detected. So here, if you go to the ensemble block, and that's okay, where is our example? This one, right? And here we have selected the box threshold 0.5. So in detected text, we should keep it lower than 0.5 so that it has it detects more region than a model has kind of missed. Okay. And then what we do, we just model identified a region and tesseract based identified text region will simply combine them. Okay, so we are combining here in layout. Next, what we'll do, we'll just identify some gaps. Okay, so for example, we have regions where there's no text available. Okay, so we'll identify those spaces and all those things. Okay, so for that, what we can do, we can define a method detect gap. Okay, so for that, let me define that method quickly. So next method could be detect gap. The method. Yeah. So this method will detect the gap. So it is expecting the layout, then image shape, and then minimum gap size is 50. Okay. So like that, the width basically, okay, based on image. So what it will do, this function finds empty spaces or gaps in a document layout. And these are the key operations, what we will be doing in this method. So it will create a binary mask marking detected region, or whether 0 means no, 1 means yes. Invert mask to highlight the gap. Okay. So basically, I'll explain this part. Okay. So find contours in the gaps, return gaps later, larger than the minimum gap size. Okay. So that's what we are doing. So let's understand these code lines one by one. Okay. So here we just identified the height and width of the image. And then what we are doing basically creating a mask of detected regions. So whichever region we are kind of have some text, right? So wherever we have text, whatever regions are being detected, we are creating a mark. And then we'll just do one minus. So all the remaining where there is no text available. So that means there are gap or spaces. So that's what we are doing with the inversion, right? And then create, so whatever regions we got, we'll convert them to identified blocks basically, right? So kind of where gap is available. So that's what we are doing here. Okay, and then we'll return all the gap blocks. So that's what we'll do here. So now let's go back to the pipeline. So we have kind of identified ensemble, we have identified layouts based on those two models in this method. Okay, and then so of course based on ensemble, so like where we are combining the layouts for those two models, that logic is here. Then we have identified the text region with lower confidence with respect to text rect. And then we identified, I mean, we combined those layouts so that we have more layouts available. And then we are identifying the gaps. Okay, just now we see. And for that, we have even lower the confidence, that 0.2. And now what we'll do, combine everything. So we combined everything like this ensemble detection and then text detection using tesseract. We combined that one, then we detected the gap, and then we combine everything till here, right? And now what we will do, basically in this manner, so there could be some overlapping reasons like identified multiple times, right? So that's what we'll define here. So we'll try to remove those overlapping reasons. Okay, so for that, we need a function. So let me define that one. So what I'm doing here, I'm trying to remove the overlapping region. Okay. And here I'm giving IOU threshold. I mean, how you will identify overlapping region? Basically, you need to identify the intersection. right? And for that intersection threshold, I'm setting 0.5. So if overlapping region confidence is like 0.5 or above 0.5, then of course it will identify this as overlapping and it will try to remove. Okay. So for that here, you see, I'm using one more reason, like because I need to compute the intersection or union. I need to compute the overlapping region, right? So for that, you need one more method. So let me copy that as well, and then I'll explain one by one each line. Okay. So yes. Okay. So first, let me explain this method, then I'll explain this method because this is being called inside this one. Okay. So it says compute IOU. So IOU means intersection over union. Okay, it will prefer intersection. So this function calculates the intersection over union between two bounding boxes. Okay, because we need to like remove the overlapping region. So it is intersection, not union. Okay, so because in union some part will not be overlapping. So IOU with all the layouts. So IOU measures overlap between bounding boxes ranging from 0 means there is no overlap and 1 means perfect overlap, and used for, I mean, in this particular object detection accuracy review. So what we are doing here, so in this particular box, we are kind of identifying the corner edges of the overlapped region. I'm sorry, intersected region. Okay, so which one is intersected? Okay, so for example, in box 1 and box 2, we have block x1 and x2. So like in like so basically if you just imagine two boxes and they have some overlapping region, so in x-axis will get the leftmost edge. So that's what we are doing here, right? So likewise, so if you just imagine this particular section, then we are kind of just trying to extract the overlap, so intersected region basically. Okay, so for the particular for the set of blocks. Okay, and if there is no overlap, then of course we'll return 0. And then here we need to return the ratio of intersection over union. So that's where we identified intersection region, okay, area. And so area is what? Width into height, right? So that's where x into y. So that's what we are kind of x2 minus x1, it will be width, and y2 minus y1 will be height. So that's where we calculate the area. And area 1, that's like area of box 1 and area of box 2. And then of course, from that area, if we remove the intersection, then that becomes the union, right? Because intersection region will come twice in those two boxes, right? So it's simple mathematics, right? Intersection will come twice. So one time we removed, then we got the union, and then we simply got the intersection divided by union. So simple score, IOU score, right? Okay, and that will be used for uh, removing the overlapping region. And now understand this method: remove overlapping boxes. So this implements non-maximum suppression. Okay, so that's why like based on the threshold of overlapping. Okay, keeps highest confidence detection while removing lower confidence overlapping boxes. Okay, and that exceed the IO threshold, helps eliminate duplicate detection of the same object. Okay, so that's where we have calculated IOU. So now here you see, like so basically we want to only keep the like non-overlapping region. So that's where we defined a list filtered boxes, and non-overlapping region will be separated in this one, and this will return. Okay, so that's why like here what we are doing, I'm just sorting the boxes based on their confidence score. Okay, and then based on the sorted boxes, we are just iterating, and what we are doing, just popping one by one basically. Okay, and we are checking. Okay, if so let's see here. So compute IOU of those both the boxes. Okay, current box. Okay, and the box which is coming from this sorted boxes. Okay, and if it's threshold, so because see, we have, suppose in the sorted boxes we have 10 boxes, sorry, 10 blocks. Okay, and there could be some overlapped blocks. So we have to check each one with other. So if it is overlapping with anyone, if it is overlapping, then of course we'll remove that one. So that is the logic happening here. Okay, and the decision of overlapping is based on IOU score. I hope you got this logic, right? If there are 10 blocks in a sorted box, then we have to check each one with respect to others, each of others. And then if there is overlap, then of course we'll keep on removing that one. That's where here it is a while loop. Okay, and then ultimately we'll return the filter box, so there is no overlap. Okay, so now we have understood all of these methods. So let me just instantiate each one of them. Okay. Okay, so we have defined basically properly, and now if everything we have set up correctly, then this pipeline should work. Okay, and here we are expecting image. So let me get this image. So you see in our previous video we have this notebook ran. Okay, we have defined this image. So that's how we can take this image. Okay, and I'll have this image. So I can just paste it here so that everything will run in sequence. So now I have this image with me. Okay. And now I think I can call this method. Yes. Okay. I mean, so I have still just defined the pipeline. So I still need to call this. Okay. So for that, let me put this code here. Okay, so all the pipeline method I have defined below. Okay, so here I'm just so basically you don't need this because I have already defined the image. And in image, so like by default, CV2 will read in BGR, that is a blue, green, red format. Okay, but you can convert to RGB format. I mean, if required, you can just ignore that as well. Okay, so that's not. And then we are just calling this method, and then we'll draw that one. Okay, so let's see if everything is fine. It will just draw the bounding boxes correctly. Okay. And then we'll just try to compare with the single method where we ran the mask RCN independently, and then with this ensemble one, okay, with lot of post processing. And then we'll see like whether we are getting better result, better identified reasons or not. Okay. So let's wait few more seconds. It will it will run in a minute. Okay. So it's around 351 MB model size it is loading. Okay. So, I mean, around, yeah. So let's wait few more seconds. Yes. Okay. So now we got the output. Now, if I show you the output, then see, it has tried to identified almost every block. So here you see, so I cannot open side by side, but let me show you the previous output for a moment, right? So here, if you see, so it has not identified every block. So for example, it has not identified this. And again, this background. Okay, so here I just loaded the BGR image and there I just converted to RGB. So that's where it became blue. So don't worry. Okay. So here, but the important thing is like it is the same image, but it has not identified this or these, and even not even identified line and here internal boundary, right? But after applying Ensemble, okay, after applying Ensemble, it has identified everything, you see, right? Okay, and if you're confused, so let me, I can do, let me load this image again, okay, and I will simply remove this part so that it will be clear to you that I'm using the same image, okay? So let it run again. So just wait few more seconds. Okay, so now we got the image. Yeah. So now you see, so it is the maroon or maroon color, right? Background. So it's the same image basically. But the idea here is like, see, it is identifying more blocks, almost everything accurately. And now we can easily extract text for this. And you see here, it is identifying summary with this yellow, and then lines, corresponding lines with like orange lines, right? So here experience heading, so everything it is identifying perfectly, right? Even you see the this boundary. So in our single model, it was not identifying the inner boundaries, right? It was only identifying the outer boundaries. But here it has identified the inner boundary as well. And almost everything it has identified. So that's where we saved lot of fine tuning. We no need to do the fine tuning, but still with the help of ensemble learning, we are successfully identified the almost everything, right? So now this is all about ensemble learning. I hope you learned something if you have executed along with me. But now, in the next video, what I will do, I will try to show you extracting this text. Okay, extracting this text, and also I will try to show you like defining the color coding. So, for example, if there are title, it will identify this with different color. If it is a plain text, it will identify with different color. If it is a list, it will identify with different color. If it is a table, it will identify with different color. Okay, and based on that color mapping, I will just try to extract the text. So that mapping will be very straightforward. Okay. So we'll see that as well. Okay. In the next video, so that this video doesn't go with, it doesn't become lengthy basically. Okay. So that's all for today. I hope you learned something. And if you have any doubt in installing these libraries or anywhere if you stuck, just message me, we can discuss. Okay. So that's all. Thank you.